start with number 3. Y equals 8. Okay, so, we have to think in terms of the rules that we've learned. One of them is the constant rule. It's a constant function, a function that's never anything but this one number. And if y equals 8, let's remind ourselves of why this makes sense. Here's our graph, or our axes, and y equals 8, so here's 8, and y equals 8, y always equals 8, right? This is the graph of y always equaling 8, just a straight line. So what would be the slope of a tangent line to this line? Well, of course, the tangent to this line is going to always be the same no matter where you are, and that tangent line is going to be flat, horizontal, and the slope of a horizontal line is 0, right? So y prime would be 0. That's one way we say the derivative of y. Okay, we might also say dy dx equals 0. The change in y, this tiny, tiny change in y over this tiny, tiny change in x, is 0. Okay, let's go on then. That's the constant rule. The derivative of a constant function is just going to be 0 because the slope is always the same. It's always 0. Alright, 18 f of x equals... I hope you're not watching me write this down. This is really boring. Should fast forward through this kind of stuff. Okay, so we should know how to find the derivative of this and of this and of this, and we should remember that the sum and the difference rules tell me that basically anything is separated by a subtraction or an addition. I can take the derivative of this and subtract the derivative of this and add the derivative of this. So let's look at this one first. Let's break it down into its most basic rules. I should recognize this is something I can find the derivative of easily using the power rule. But do I have a rule that I can take the derivative of this and somehow take this out of the whole equation? And in a way I can. We've got the constant multiple rule says that if I want to find the derivative of this, I can take this off to the side for just a second. Basically the derivative, this is how we say take the derivative of this thing. Take the derivative of 2x cubed, and I can take the 2, it's like I can factor it out and kind of, to use a term that hopefully makes sense. And so now I can take 2, multiply by the derivative of this thing, and then I'll have the derivative. Okay, so let's keep going. Well, I definitely know how to take the derivative of x squared with the power rule, right? And then plus the derivative of 3x. This, I'm going to rewrite these. This stays the same. And the constant multiple rule tells me 3 can come out here and be multiplied by the derivative of x. 2 times the derivative of this guy. The derivative of this, remember, is take this, multiply it. It becomes the coefficient of the x, and then this loses a power. So this is 2 times 3x squared. See how the 3 became the coefficient. The 3 lost the power, so it's squared now instead of cubed. Minus, same thing here. 2 is the coefficient x to the 2 minus 1, which is 1. So we can keep going here. 3. And then the power rule still works here. This is to the first power. This comes down, becomes the coefficient times x to the 1 minus 0. But all this amounts to is 1, because this is 1 times, and anything to the 0 is 1. 1 times 1 is 1. So let's clean this up. 6x squared minus 2x plus 3. There's the derivative. Alright. 32. I've lost it. F of t equals 3 minus 3 over 5t. And they're giving us this point 3/5 2. 3/5 comma 2. Okay, so we want to find the slope at this point. The slope of this graph at this point. Okay, we could do the whole limit thing and plug in 3/5, but of course you don't want to do that, because if we do this instead, f prime of t, then we can just take the derivative of this minus the derivative of this thing, yeah, we'll keep going. This is going to be the derivative of a constant is 0 minus, well, this is where it gets maybe a little challenging. I want to rewrite this function so that I can use the rules that I have. The first thing I'm going to do is say, look, this is the same as 3/5 times 1 over t. I kind of take the constants and bring them out together, 3/5. And now I just have 1 over t, but I don't have a rule for this exactly, right? Not exactly like this, but if I rewrite it to use the power rule, now I've got something. Now I've got something to a power, and I can use the power rule. And the power rule would tell me to take this power, bring it down here. That's -1 times t to the, and then this loses a power, goes subtract 1 from that -1, you have -2. And so this is 3/5, right? -3/5 times -1 is going to be positive 3/5. And this would be 1 over t squared. That's what t to the -2 is equivalent to. So we could just go with 3/5, 3 over 5t squared. And then it says find the slope of the tangent line at this point. So let's put in 3/5. 3 over 5 times 3/5 squared. Right, that is the derivative. F prime of x is the derivative. This would be 3 over 5 times 9/25. And let's see, the 5 down here would cancel with this, making this a 5. 3 over 9 over 1. Okay, I make this long like this and bolded so that we can see that we're dividing this by this fraction, which means take 3 and multiply it by the reciprocal. Cancel, cancel, this becomes a 3. Excuse me, this is a 5. My apologies. So that becomes a 3 in the denominator, and we're left with 5/3. 5/3 is the slope at that point. Alright. And now we are going to do 44. H of x equals 2x squared minus 3x plus 1 over x. Okay, now this looks like a doozy because I don't really have any rules for this. If it were just the numerator, I would be in good shape. If I just had the denominator, I could probably pull that off. But how do I handle the way this looks right now? And we need to rewrite it. Well, we don't need that right now. we need to rewrite it so that we can use the rules that we have. We've got the sum and difference rules, we've got the power rule, we've got constant multiple rule, we've got the constant rule, all these things. But we don't have anything for a function divided by a function as of yet. So what about instead of all the stuff divided by x, we do like 1 over x times all of this stuff. And instead of thinking as 1 over x, it's x to the negative 1 times 2x squared minus 3x plus 1. And now we multiply it through 2x, right? X to the negative 1 times x squared would subtract 1 from 2, and you'd have 1. And then this would be negative 3, and this would be plus x to the negative 1. So now if I wanted to take the derivative, h prime, okay, the derivative of 2x, the 2 comes out, we take the derivative of x is 1, and so 2 times 1 would be 2, minus, the derivative of a constant is just 0, plus the derivative of this, which negative 1 comes down, becomes into coefficient, times x to the negative 2, and so 2 minus a negative x to the negative 2 equals 2 plus 1 over x squared. Okay. The reason it's that way is because negative times negative is a positive, and then I just change this to be more proper, 1 over x squared. We're going to do one more, and it's going to be number 58. So, what's y prime? Well, let's see. Determine the points, if any, at which the graph of the function is horizontal tangent line. Where it talks about, like, find a point where the tangent is such and such a thing. We're going to find the derivative, and then we're going to talk about the derivative. So let's first find the derivative. This comes down, becomes a coefficient. This loses a power, so it becomes squared. And this power comes down, it's a 1. And that's times x to the 0, which is 1, so 3x squared plus 1. So now it says find the points at which, if any, there may not be any, but at which the graph of the function has a horizontal tangent line, a flat tangent line, which that's a slope of 0, so the derivative, the slope, is going to be 0. Whatever x we put in here, we want it to wind up being 0, so we're just going to solve for x. And you'll find that x. So subtract 1, that equals 3x squared. Divide by 3, so negative 1/3 equals x squared. Take the square root of both sides. The square root of negative 1/3 equals x. And now we should see that condition in parentheses there that says if any is there for a reason, because we cannot take the square root of a negative number, right? This would be like I root 1/3, and that's not very good. Not t. I root 3 over 3, and this is not going to work. So that's not a real value. There are no real values of x that have a horizontal slope for the tangent line at that point. So, none would be the answer. But if this worked out to be something, some real number, that would be it. That would be the x value. And since we're taking the square root, we'd have a plus and a minus. So over here and over here are values of x that have a horizontal tangent line for that graph. Okay, hope that was helpful. See you next time.